Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this latest episode of the Trend Detection Podcast. I'm really pleased to have a couple of external guests today from a company called Very, a really interesting IT and technology company. And we're going to talk today about data, and something we've covered a lot on the podcast, definitely, but it's always great to have a different angle and a different viewpoint on this really important topic. So I guess before we get started, I'll hand over to our two guests just to sort of introduce yourselves. So Ryan, maybe if you want to start.
Yeah, nice to be on the show today. Thanks for the invite. So my name's Ryan Prosser. I'm the CEO of Very. We're a IoT product development company. I also host the Over the Air podcast, and we've been very fortunate to have some of your folks on the show. So very pleased to be here with you today.
Excellent. Daniel Fudge, I'm the Senior Director of Software and Data Solutions at Very. And as always, love to be talking about data anytime. So if you give me an offer to stand up and talk about data, I will show up. And here I am. So.
Excellent. No, excellent. And thank you for both agreeing to take part. I'm really looking forward to this conversation. So I guess just to start with then, so for people who don't know, so Very, what do you guys do? What is your sort of offer to the market?
I can take that. So we are an IoT-focused product development company. We focus on mostly commercial and industrial applications, which is how I think we've come to know you guys quite well over the years. Based in the United States, but we've got operations globally. We love hard problems, so we are we do well in harsh environments where comms are difficult and data is important. And Dan will talk a little bit more about that today, but yeah, that's kind of our bag.
Absolutely. Well, we're basically a group of engineers that, as kind of Ryan said, we all get really excited about hard problems. We're here. We work with people in all kinds of different aspects, but at the end of the day, it's trying to get, you have device, trying to get connectivity, try to bring intelligence to the world. That's our bag and that's our thing. So it's good fun.
No, excellent. No, sounds it. So in terms of, let's zoom out, I guess, a little bit first of all. And we're going to talk about things like AI and how that applies to data as well. But why don't we zoom out a little bit and start with, why is high quality data, so important? Why is that important to people?
I've been around for a little bit. I've got a little bit of gray here, so I can kind of take you a little bit on a journey. When I started out way back in the day, we call them, surrogate models or high dimensional response services. And we basically we hit three things. And this is the thing that we all survive with. And we now have enough data we can get past, but the number of data points that you need, the dimensionality of the data, and I'll call it the reliability of the data instead of the quality of the data. But when we really first started, a lot of the models out there, we could do the textbook problems pretty easy. But then when you hit the real world, all of a sudden, those models, they just couldn't do it for us, right? And so we realized we were missing a lot of information, which is like dimensions, extra dimensions on there. And so we started going in, getting more information, adding more dimensions to the data. But there's, something out there called the curse of dimensionality, which is once you get more and more dimensions into your space, you need a lot more data. It starts growing exponentially, the amount of data that you need. And as you start getting all this other data, you start realizing some of that data that you're getting, those new dimensions, it's just the reliability is not there. A great example that I always like to say is when we started doing machine vision and, you're starting to label the data for things, we would show the same images to multiple experts. And then we started realizing, because they were coming back with different answers, we'd give the same images back to the same expert over and over again. And you'd start seeing there's that difference. So trying to build a model that's more accurate than the data that you have is basically impossible. So, again, you need a lot of data, you need high quality data, high dimensional data. And this is something now that the world we live in, the data is everywhere. And so we can start building those models, which is fantastic.
Yeah. And in terms of what you're saying there, Dan, in terms of when you consider high quality data versus lots of data, what's the right balance there? I mean, you might say both, which answers the question quite succinctly.
Yeah, no, exactly. The answer that engineers always say is depends, right? And it's very, very true. There is a big debate about there whether or not you can get to that intelligence with just pure amount of data. And if you look at things like ChatGPT or GPT models, large language models, that's kind of one of the things. They're looking at a mountain, a sea of data, and you can start making a lot of that connectivity. So it's a trade. When we were doing, especially very targeted type of modeling, you can get very accurate models with not a lot of data. We're talking, even like in the thousands of points. If the data is very high quality, targeted in here, if your data starts to get noisy, a lot less, then you've got to get more and more data to kind of balance that off. So yeah, it depends, but it's a trade. I would always rather have high quality data, just makes your life much easier. But if you can't get high quality, you kind of no replacement for displacement, and you just got to go big. But then you need much larger models. The more data you have, the size of your model starts to inflate. And that's why high quality is a lot better, because you can get there with a much smaller model, which, when we start talking edge computing, small models are great, right? So.
Yeah, and how does that sort of that debate between the two correspond to like AI as well when you apply AI to data as well? Is it in terms of quality versus
Yeah,
how much data you have?
and the term AI, I always say it's like a suitcase term. You can fit just about anything in it, so it can mean a very broad variety of things. But it's the same thing, right? AI, machine learning, or even we get into a lot of in the AI world or in the IoT world. It's not just machine learning, right? There's an awful lot that can be done with signal processing, a lot of more traditional time series analysis and things like that. There's a lot of things in the toolkit. I will say a lot of the more traditional methods, though, you have to have good, high quality data for. They rely on much more clean data to get working. The advantage and the reason why I think machine learning in general has really exploded is that they can be huge and they can handle huge data, and so you don't have to have that very crisp, clean data set to kind of leverage. But again, I'll say it over and over again. That means you need bigger models. That means you need to have more data. So there's no free lunch, right?
No, absolutely. And I guess on that note as well, do you feel that maybe it's an obvious answer as well, but in terms of like AI machine learning, is it something that's is it a term that's sort of overused or maybe even misunderstood in terms of what it can do? It's amazing, but is it too much that it's magic? And we get that a lot as a sort of an AI based product, is that it's plug it in and the magic will do its thing.
Yeah,
But
sprinkle AI, sprinkle AI. I actually had
yeah.
someone at some point came to me and said that, and they were serious. And it's like, okay. But I actually use the AI term strategically as well, because it can mean many things, right? Because it does cover, and there's a lot you can do besides machine learning. Is it overused? Absolutely. One of the big things at Very, we have a very fantastic design team, and their product design, the whole journey. And that's where I always start any conversation is, okay, you want AI in your system. Fantastic. So let's sit down. What is it that you actually need your system to do? Right. And start working through, we call it needs, wants, and desires. Right. What do you actually have? What are the constraints that you have? Because the solution, if you can do a solution simple versus complex, simple is always better. Right. If you can get it there simple, it's understandable. Maintenance is going to be a lot easier. You don't need a PhD to kind of understand what's happening in there. So that's huge. So I always start with the simplest solution first. If we can get there, don't want to give too much away, but we've actually got a test when we do our hiring, and it's a little bit of a trick question in there because I give people a pass if there's a very simple answer. I'm not going to give it away, but if they just say the very simple thing, it's like that's a pass, because simple solutions, if it works and it meets the requirements, you stop there. But in today's world, the ability to go and grab those big, it's almost a double-edged sword, because you can start doing it so fast, right? You can get running with those big complex solutions. But you should be very cognizant of that. You actually need the complex solution, or is a simpler one very sufficient?
Yeah, I like what you were saying there before about sort of focusing on sort of business outcomes, because I think that's part of the problem is people focus a lot on the technology. Oh, what technology do I need? Should I buy this technology? Oh, it's got AI. I've got some budget for some AI or Gen AI technology, but it's without thinking about the business outcomes. Is that something you sort of promote yourself as well?
That is a huge part of my job as as the director of data solutions and software. A lot of times in those engagements, that's where when we first start talking, they bring me in, and that's kind of what I'm trying to. There's a nice slide that I usually walk people through. It's a journey, right? The many stages of analytics. You start off very descriptive, very simple, before you work your way up. We always kind of walk people through that journey. However, you have to be very aware of the reality. We're talking with people with businesses, and in today's world, being able to say that you have AI in your system it's almost table stakes for some industries, right? So you have to walk them through. Okay, what do you need to do? What's the business outcomes? How can we bring these together where you can both satisfy, I'll call it the engineering problem, but there's also a higher level business problem that you're also trying to solve here. So yeah, in today's world, having AI in your portfolio it's almost table stakes.
No, absolutely. And I guess we maybe could have started with this. What I was just going to move on to is actually the collection of data and the role of sensors in collecting these data. I mean, how is that? What's their place in sort of optimizing business operations?
Yeah, absolutely. So, as we've been said several times, all the machine learning in particular, it's just built on data, right? Without it, it's nothing. So, data is the cornerstone. There's many types of data that you want to get in there, and I will say that there's kind of two big worlds here when we talk about data and how we kind of optimize for it. Is there's in a very narrow domain, you get into predictive maintenance and things like that, where a lot of that is just exposing. You're going to have to build out a really good, robust data engineering pipelines to connect to the data across your organization, bring it together, right? And so that is one of the things that we really want to focus on with folks is making sure you understand that data. And then for your sensors, a lot of it's going to be, okay, understanding the state of your system, right? We get in there, we start saying, you kind of have to have your eyes. They are your eyes, the sensor in all the different domains, deploying them out, getting them back in, getting that data going. And as I kind of mentioned before, as you start this and you start predicting, your first few predictions, okay, break news to everyone, are probably not going to be great. Or your time horizons for prediction is not going to be good enough where you can really make a big impact into your business. So the first thing you say is, I'm missing information. I kind of mentioned dimensions. For me, that's additional information that you're missing is these different dimensions. And that often means different types of sensors you have to deploy, strategically placing them. So this is the thing I think is really important, is that people have to understand their business. The best people to talk to are the people on the floor who understand this process extraordinarily well, right? Talk to them. What's important? You talk to some of those folks, they know a system's going bad. You say, why? It's like, well, it sounds this way. It's like, okay, there's an acoustic signal here. So that means let's try to find some sensors that are in the sound. That's something you're looking at. Is there a temperature? Is there things that a lot of people that have been working around that system for 20 years, they understand? And so that's the thing you're trying to automate and try to deploy those sensors in to capture. So you get that, again, greater dimensionality into your data, richer data, so you can really start predicting out further and further to make a bigger impact into your business.
Yeah, I guess that's an interesting question because we were so focused on the software side before we were acquired by Siemens. So before Siemens, we didn't offer any hardware we worked with partners and others, so we weren't really in that necessarily selling sensors and things like that. But I just wonder whether when you're talking to customers, presumably there maybe some sensors installed already. Is there a case that maybe they've bought those sensors maybe for the wrong reasons? I don't know, but because you're talking about very sort of talk to the people on the floor, really get an understanding. But is it a case well, is that not always the case, presumably?
Absolutely. So and there's two kind of things there. One of the taglines we usually say all the time is crawl, walk, run. And so the idea that you're going to come in and just deploy the perfect sensor suite in the first run, and then you're going to deploy the models, and then it's going to get you your business value in this nice straight line. Very seldom happens. That's why I say the crawl, walk, run. You want to get in there as rapidly as possible. One of the big things at Vary, we try to do speed. We try to do speed because we want to get in, connect that, we call them like tall vertical slices, get that data right from the sensor all the way back out, try to make some predictions, because that's when you see the holes in your process. I always tell people when there's things that you can't do, or errors in your prediction. In many ways, that's gold, because now you know the problem area. Now you know the thing to focus on. It's like, okay, we can't do this, therefore we're missing information. It's all about information, right? So it's old information theory. We're missing something. That usually means sensors are a big part of it. It also might be adjacent systems. That's why I kind of put out there as well. There's job tracking, because it might be in this machine that you're working on. It might be because there's a machine to the side that when it cycles, it causes problems here. So understanding that whole, holistic view of your process end to end. It might even be ship changes. Sometimes it's not the machine. Sometimes it's that, Tom likes to do this and start up, and Jerry likes to do something else, right? So understanding exactly how that system operates is critical. And you won't get that on the first run. You're going to have to do a few iterations, right, to kind of nail that down.
No, of course. I think that makes a lot of sense as well. But in terms of data, I mean, I've had conversations with, I've been to events and been on many show stands talking about data as well. Data is one of the most common words I hear in my everyday world, let's say. But from their point of view, in sort of industrial manufacturing environments, I get this feeling that there's a lot of data being collected. Maybe Industry 4, and collect all this data. It's going to be really useful to you, but there's maybe a bit of an understanding about how then to use that data for the real business value and those business outcomes we talked about before. Is that your experience as well?
Yeah, we always call it the swamp, right? You're going to get your data lake, but it's a data swamp that happens real fast. And that's why, going back to that idea again of not just, throwing all the sensors you can think of, throwing everything at the wall and getting all the data back, because you'd get flooded as well. It's got to be sharp. It's got to be clean. You got to be picking up the right things. One of the classic examples that most first year, I won't call them first year, because probably most people don't do it in school, or at least not when I came through. The first time you really try to do this is you take every piece of data you have and you chart to see, can you build a model for this, and you optimize this signal, that signal. But all you end up doing is fitting the data that you have at that particular time. It's got to make sense. If you can't kind of, in 2020 vision, you mightn't have known it before, but if you can't understand why this signal impacts that, someone who understands it, it's probably just noise you're pumping into the system. It might work for that current data set, but a month from now, it's probably going to be silly, right? So understanding that data, you don't just throw it all in and, turn to black box and expect to see greatness come out. That domain understanding is key, and understanding why these things impact that. And then there's a great loop that happens, because now you talk to, I've had this many times, you talk to the engineers and you say, well, this seems to impact it. And they look at it and they're like, oh, I didn't think of that. And so all of a sudden there's that human machine interface and that learning that happens. And then they all of a sudden have a better insight into their process, because that signal is important. Okay, why is it important? That'll probably lead to, have you looked at this? And continue on and on. So it definitely has to be this, the spiral that sets up, and you get better and better as you go, human and machine. So your models get better, but also the people around you get to understand their own process better and better.
Yeah, and I guess through that process, you identify, I guess, different use cases to apply this to. Maybe there's some examples of use cases people utilize with their data. Is there some insight you can give there?
Yeah, I mean, I think insights into your data, I mean, there's the obvious ones, right? The first thing you could do, descriptive, which is anomaly detection. Most basic, classical statistics, anomaly detection, you're looking at things. You can do that. That's why that journey I always talk about. That's something you can do almost right away. And I think the only way that this works is that you have this incremental approach, but you have to deliver value at every step of the road. You can't expect to go and like have a business plan where you start this, oh, don't worry, 2 years from now, we're going to have an awesome system and not provide value. So you're going to have to start in. That's why I always do the simple stuff. Make sure, anomaly detection, start to get those types of things. Then you start doing deep dives. You can start saying, okay, now I understand why this is happening. I can now start to build bigger and bigger models. Again, the prediction is kind of the holy grail that you're kind of going for, to be able to predict out performance. Because then you could start saying, I predict the performance this way and it deviates. That's like another type of anomaly detection, where the real system starts to deviate from a prediction. One of two things: your model's not great, or something's happening with that system that you haven't seen before. And so that's a great thing to be able to grab. And then once you get to a point where your prediction is very reliable, then you get into, okay, how do I control it? This is, you're starting to be able to prescribe actions. And based on that, this is, again, where myself and a lot of other people, the reinforcement learning idea, right? This is where we would love to be. But to be able to do that reinforcement learning where you predict or you give actions to take, you have to have an environment that you can properly replicate. And that's kind of where you want to get up in that journey, but you got to start at the beginning. That's like the shiny thing at the top that you hope to get to, but start early, work your way up. And there's probably another completely different aspect there. We've been talking very much in the predictive maintenance world, but there's also driving intelligence further and further to the edge, which is very much a different animal. But instead of kind of bringing it all the way back to the cloud and working on it, it's starting taking those things, those control, I'll call it, and putting that control locally to the system closer and closer. Once you have a model that can actually predict and respond to the environment. I think that's another very exciting thing, especially in the last few years where the hardware is just getting better and better. We can start deploying.
Yes, but maybe go into that a little bit more. So, why, edge, that adoption of edge is becoming more, prevalent now. Is it more? We can go into that.
Yeah, I think there's the obvious benefits that have been around for a while that we can chat about, but I think also there's like a discussion of why now versus 5 years ago. Why is it that we're getting to the point where people are starting to push everything? You go into any of these, conferences, edge computing is just all over the place, right? We have our wonderful stock that we're all watching is doing wonderful, right? And there's reasons why. So I think there's two big drivers here. This is the Daniel Fudge opinion. Is that one, the hardware? Now you can get a lot of systems on package, a lot of microcontrollers, all the big names. They're all starting to deploy packages where you don't have to do a lot of the low level engineering firmware work. A lot of packages are there. It's very much from the software world where this has been around for a long time. You have packages that you just go and pull. You don't restart from zero, right? In the hardware world, we're getting to that state where there's a lot of great packages that you can go out. And then the models, you can go out right now to the NVIDIAs and others of the world, and they've got models that are pre-trained that can do a pretty good job to get your, that crawl, walk, run. You can get something rolling in the machine vision world, in the automatic speech recognition, pretty fast with some of the pre-built models. You're going to want to fine tune them once you get rolling, but that idea of getting out quick and getting a system up, you can now do that much faster than a few years ago, 5 years ago, that would have been, you needed PhDs on staff to be able to put it together. But now we can kind of come in and you just have to, it's an engineering task now, not a research task to put these systems together.
Yeah, and I guess one word we use a lot within Siemens and within Senseye Predictive Maintenance specifically is this word scale. I guess, does it help with that aspect as well? And completely getting what you're saying about it's a journey. You won't get to scale immediately because you have to sort of prove value first. But is all this built towards scaling solutions?
Yeah, and so what I was talking about was the when and then the why, right? And so the scale is one of the big whys that you have. So if I was going to say, what are the big whys of why you want to do it? The first one is like latency, right? If you push the intelligence further and further to the edge, you can respond much faster instead of having to push it all the way back to the cloud if you had your intelligence in the cloud. So going to the edge computing, just cut your latency down. Now you can start getting real time, right? Versus having to go all the way back up the chain and come all the way back down again. So yeah, your latency is the big one. The other one, of course, is security. Having your assets, having your data local, never leaving the device. You don't have any of that in transit security concerns, right? So your exposure for in transit. And then if your data is localized, which helps with the scale problem a bit as well, you don't have like one spot in the cloud that has all your data for everything, which of course, a single breach, the blast radius is huge, right? Because you've just exposed everything you have. Whereas if it's more modular, again, software world, there's a lot of these concepts now being applied to hardware. Now it's just down here, it's modular. The scale idea is that you don't have to be pumping all that data. You basically have, this is a question about how old you are. I can remember the day when we started networking all of our computers at work together, right? To be able at night, everyone's systems would be there, we'd all connect them and we'd be able to go and push things out to them to do. But it's that same sort of idea of, instead of building one massive center or paying someone for massive compute, all of these systems can handle a lot of the load. And to scale things, doesn't matter if you're 10, 20, 100 units. You get tens of thousands of units. That's a lot of compute power that you got. Each of them don't have to be huge. So it helps with scalability in that compute. And then the communication. You don't have to pump all that pipeline back into the cloud, which is scale, cost, this cost of bringing that all in, and just building the pipeline, right, is a big endeavor. So now you just need to have a trickle, because most of it's happening at the edge.
And if we sort of apply, a lot of what you said there, not just on the edge, but if we're talking sort of cloud and, and just infrastructure in general. So we work a lot in sort of heavy industries, mining, metals, and obviously that requires a more rugged type of approach. Rugged approach, I don't know if is that the right phrase, I don't know, but or at least the hardware and the sensors and connectivity, there's different considerations. Is there, what are those considerations, I guess?
We've got a classic pattern. We don't have the platform idea, but we have a lot of standard patterns. And so for hardware as well, there's a very standard pattern. It doesn't always go this, but to your point, I think it's good for a concept is the node, gateway, cloud, mobile, kind of like those four pieces of the pile. And so especially when you get into somewhere where it's connectivity is very hard, a lot of local, we have the node, which is the very light microcontroller. It's probably the thing with the sensor at the very end or near the actuator. And then we'll have a gateway. The nice thing with that is your node can be, like you said, this is the thing that's going to be out in the world that's going to be exposed to all the nasty, right? So it's got to be built super rough, super tough. If you don't have power, for instance, and you're on battery, it's going to have to last for years on battery. So there's a lot of really tough environment to build that thing out. It's probably going to be custom because it's going to have to be lean and mean. But you can now compute back to or communicate back to what we call a gateway, which is local, but then can service 100 or 1,000 or however many nodes that are in that area, maybe over some sort of wireless like a LoRa, which is great for penetration if you're in some areas, or long range. You can get into the miles type of range. It's nice. Then when you get to gateway, this is somewhere in a much more humane environment, right? This is probably in some sort of server rack, some area that's nice, so you can start going off the shelf. It doesn't have to have a lot of those requirements for durability, but it can then consolidate, maybe do some intelligence. We talked about pushing things to the edge. The edge is not just at the very node. The edge is also at that local gateway. So now you're probably on a Linux machine instead of some sort of real-time operating system. So you can start doing some bigger lift there, and then the gateway back to the cloud. And eventually you're going to bring mobile into that mix. But those three pieces gives you a lot of flexibility when you go out into the field, because you can think about where do you push your intelligence, the communication. We've broken it up into two pieces now, from local to the cloud, and then from the gateway to all of your devices. Gives you a lot of flexibility with that general pattern. And it's very nice and robust. There's no doubt about it.
Yeah, and you mentioned sort of wireless solutions as well. I mean, how is adoption of those now growing, and maybe what are the reasons why that's the case?
Yeah, I really most of our clients, there is a wireless mix in here. I mean, in an ideal world, you all had a nice LAN and you just plug into and it's all great. But in the reality, there's always going to be, or nearly always going to be, some sort of wireless connectivity. And again, two different types of wireless connectivity. I'll call it the local, trying to make your local. And that's where it might be something like maybe a Wi-Fi, maybe a LoRa, and then the cell. Some of the big things that are really changing here in this space, range. If you go to any of the conferences, satellite connectivity is kind of the new big buzzword that's out there, right? And that just opens up. You kind of mentioned the agriculture, mining, oil and gas, energy, those types of things where you're very distributed. You may be in an area where the cell reception is terrible. That opens up a whole new ball game. And then on the I'll call it the bandwidth constraint that comes with cellular in particular. NB-IoT, it's going to start, I've been told, moving into the 5G world. And when that starts to happen, all of a sudden, a lot of the bandwidth constraints that we have are going to start to loosen. So that's going to be very interesting. And the other one that I love is we've seen a lot more adoption and maturity in a lot of mesh type of environments. So you've got a lot of nodes, and it's just not always node to gateway. Now you can go back and forth around this network and finally find its way out into the gateway or beyond. So that just allows you to deploy your product anywhere that your business is without having to rely on that local infrastructure. That's the big thing you're unlocking, right? Where you want to go to your business, you can go now. You don't have to worry about, touching someone else's infrastructure when you go there.
Yeah. What you're talking about is that sort of flexibility, aren't you? It's more openness for businesses to grow.
Yeah. Like right now, when you think of it, there's basically nowhere on the planet that you can't deploy an IoT solution, right? Especially now, like say when satellite comes into the mix as well. Right? There's literally nowhere you can have to go now that you can't bring your system. And especially as you bring that, and I think that's the critical thing as well, is bringing that edge compute, very robust. You have to be able to have a system, especially if you're in those very hard to get to place, where the system can survive and provide maybe reduced level of functionality, but a certain level of functionality without that connectivity. But then when the connection comes, it does a sync, takes it stores the data, uploads the data. So there's more of an async communication, control back in the other direction if there's any updates need to come. But you need to be able to survive at least without internet for some duration of time. And that's one of the big drivers in your design, understanding how long can you last without a data connection.
I mean, I've, because especially when I think about the predictive maintenance use case, spoke to a customer recently, uranium producer, whose problem was that they were collecting data, but it was very intermittent. So I guess that could also be a problem if batteries run out and things like that, and then you're not collecting data for periods. That just leaves whole gaps in your data, right? Which isn't helpful for anyone.
No, absolutely. That cannot be an afterthought. That you have to assume things will go wrong. You have to assume that you need a robust system. If you go in with a system that is a snowflake, it's just not going to last very long, right? So that's got to be, it's kind of like security. In some respects, we don't talk about security enough because it's like, it's got to be there. It's not an option. It's built in on day one. And that robustness, especially being able to handle dropouts, it's just got to be there into an IoT solution, right?
Yeah, and it's funny you mentioned security there, actually, because that was where I was like, because we haven't talked about it enough at all. So, I mean, where does the security aspect fit into all this data flowing into different places? Obviously, we know it's a big concern. I mean, that sort of goes without saying. But what what are the challenges around security? In order to have all this data and connectivity.
Absolutely. I think there's obviously a lot of technologies that you deploy, encryption and yada yada. That you again have to be there from the starting point. But the thing that I like to think about is to step back a bit and say, okay, what exposure do I need? Where do I really need the data? So it's the idea of just everything goes back to the cloud. Do you really need everything back to the cloud? Because when you do that, so I'm a cloud person. I love the cloud. From a machine learning perspective, it's fantastic because I got all the compute I could ever desire, and I can like update my models real time. It's a great, fantastic place to live. But taking all that data and bringing it back to the cloud all the time is a big exposure, right? Now you got to worry about in transit when it comes through, and you have to properly think about how do you manage your data when it's in the cloud to properly segregate it. So that idea of the blast radius, right? You want to make sure all your data is properly, you're building your data infrastructure so it's properly segregated that no one can see it, get to it, possibly ever get to it unless they have to. Make sure you have all that multi-tenancy in place so that it's rock solid. But I really think about stepping back and saying, okay, do I need to send that personal identifiable information back from the edge all the way to the cloud? I don't need it to build my model. So being smart, I think about not just coming in and collecting everything and sending it all to the edge. Maybe that's the beautiful of the edge as well. I'm sorry that send it to the cloud. That's the beautiful thing about the edge is that you can then contain it in here. You can never leave that device. You can make your logic based upon it, but it can just stay there, which is, I think, a great way to kind of manage security risks. It's just exposure. Thinking about your exposure and only taking every movement of data is a risk, regardless of what protocol system you have in place. So minimizing that and being smart about it, I think, is the key part for me when I look at a system.
Yeah, I guess just on, we haven't touched upon it too much. Well, we did talk about AI before, about some of the myths and thoughts around it. We talked about it in the positive sense of it can do magic, or we maybe debunk that a little bit. But what on the other side of people who are like, give my data to AI and allowing it access to my data? Is there is there some thought behind that?
You mean the fact of, I guess when we say AI, are we talking large language models here in particular, or just in generic terms about machine learning?
No, I think we could. Yeah, I mean, Gen AI as well. I mean, that was partly the podcast we recorded very recently with you guys as well. We touched upon that and what we've implemented into our product. So maybe that serves into it very nicely. So yeah, on the Gen AI large language model side.
Yeah, I mean, I think the big thing that a lot of folks are realizing real fast is that there is the generic large language models that are out there that all the big massive folks have built. It's fantastic for generic things, but I think especially in the IoT space, really what you're going to start looking at is like very domain constrained and domain optimized large language models that have been tailored. A lot of times this is the retrieval augmented generation RAG system that you're building out around it, so you can control it and focus it. Those are great because the data doesn't have to leave your system, right? That is something where you have your data, you have your full control of data. It is just using that to steer the large language model in a particular order. I very much there's a lot of new patterns out there where it's about an agent, where you have more than one large language model. There's a large language model that's just simply, interfacing with a human, right? Getting that human text or into that initial intent. But we can start doing stuff. I love the text to SQL world, where if you have, your data infrastructure, you now can start very rapidly have a question. Can I see today's data? Or on a particular thing. We built this internally, amazingly how quick it can be stood up. And it knows your data infrastructure, all your schemas, builds a query, runs the query, gets the data back. You can now have another one that takes that and then knows Python, can build a Python script to view it. So now you can even generate a plot. I find that to be super interesting. And that is very practical and useful. It's not just, making something generative that's great for maybe ads or marketing, but it's a very much an engineering tool now. And it's not exposing your data. Your data is still in your data infrastructure. It is not leaving. It is not going anywhere. There is no inherent data exposure when you're doing that. No one else can see it. That model is yours, and that infrastructure that's around that model is your infrastructure. So that's another one I very much like in the large language model space in general. But in thinking about that in a generic term, it's that same sort of idea for any model, right? It's that is your data around. Think about how you control all your data and all that data engineering piping that has to go around it.
Yeah, no, absolutely, absolutely. And I think there's a lot of exciting. I say within from the Siemens perspective, there's a lot of exciting, enhancements around that with co-pilots. I mean, we're developing or developed one of our own as well. I mean, how do you see these tools as useful? I mean, in the sense that some might see, some people, pay a bit of lip service towards these things like, oh, it's only ChatGPT, you can ask it some silly things and stuff. But do you see it yourself, I guess personally, as like a big step forward in the engineering world?
So yeah, narrow it down to the engineering world, because like me personally, using it in the world, it's awesome, right? I mean, it's a sounding board that you can generate ideas for idea generation in general. It's great. From the engineering world, we talked a bunch about this internally about how core is large language models to IoT. What we're building here, is it a core piece? Where I personally kind of land, and this is still a discussion very much happening actively, is I view it like a mobile. So mobile, if you kind of I step back and do that pipeline from an edge device, again, the concept of like a node, edge device, local control, gateway, back to the cloud. I'm like, well, why do I need mobile? And we sometimes get customers come in and like, oh, we don't need a mobile device. It's like, you don't need it, but your user base, all I mean, how many of us can grab like this and pick up their phone anytime? Doesn't even matter if you're sleeping or not, probably even in the bathroom, right? Like the phone is always here, right? So your user base is going to be used to it. That's the interface they go to. And if you're going out and you want to be able to onboard, diagnose, having an app that you can just connect directly to the device is just so useful, right? I see LLMs and a lot of the emerging generative AI in that same space where as people just get used to it and it's not like a novelty. Right now it's borderline novelty, right? But as it just becomes the thing, I mentioned speech to text. One of the big things we're getting into is controlling devices by, instead of going to a keyboard or being able to say something. It's going to be very similar. And speech to text, by the way, that's like speech to text. Then you got to go text to intent. That starts to get into that natural language processing, large language model type of idea as well. The idea I mentioned is you're in a boardroom and to be able to say, Mr. Siemens, show me the efficiency of units 10 through 7, right? And for it to be able to come up and be shown, I think as soon as you start deploying that, they're just going to want it, right? And so people are going to get used to it. So do I think it's core to IoT? No, I don't think it's core, but I think it's just going to be another tool that your user base it's going to be expected that they can communicate in a natural language. And communicating in a natural language requires large language models. So it's going to be a piece of the pie, I guess is how I look at it.
Yeah. Yeah, I think that's exactly the right way to look at it. It's going to be expected. At the moment, we're on the sort of curve upwards, but soon it'll be, oh, why don't you have, why don't you have that, right? So
try to go around and try to find how many websites don't have a chat bot down in the corner, right?
Yeah, very good point. Very good point. Yeah, and yeah, so I guess we've really flown by and covered a lot today. So yeah, thank you again for going into this in so much detail. It's been really great. I learn a lot from these podcasts, let alone anyone out there who's hopefully listening. But I guess just as we sort of conclude, I usually just ask guests just to sort of summarize, I guess. So, and today we're talking about data and how it's used for growth. So what if someone was thinking about maybe they're collecting some data already or sort of starting very early in their IoT journey? I mean, what would your sort of recommendations be in terms of what to start thinking about? What sort of decisions should they start making now before they go into that process?
Yeah, great, fantastic question. And this is, kind of say I go to my design team who help me out all the time on this. And this is the journey that we always kind of start people on. You said value at the beginning, right? Understanding the value you're really trying to uncover is first thing, and not just for you, but like all of your stakeholders, right? Your customers, your admins, everyone that's got to touch it, trying to understand why is this good for them? What's in it for them, right? And a lot of times that's what actions are they trying to take? What decisions? How will this data influence their future? Because if it doesn't, it's just an interest, right? It's got to be something that they can make an action, it'll influence something. Then once you have that, it's like, okay, well, what data do I need to support that? And just start walking back this journey from the value to this data. Okay, but to get this data, I need these 5 other things. Then to get this, I need an infrastructure can be able to, and work back into the technology to the point you had, like, deploy a bunch of sensors. That's going, in my opinion, the wrong direction. It's got to be from that value and walk yourself into an infrastructure, not just assume that there's a infrastructure that's great for all problems, because simply will infrastructure will work. Is it the best one? No, almost every time, right?
Yeah. Again, that theme of, think of what the business problem you're trying to solve before you apply IoT sensors technology to it. It's very, very clear that's the way forward. And really great tips as well. I guess, sorry, I always do this on the podcast. I'm like, one more question, then there's one more question.
I can sit here and talk all day, by the way. So you might have noticed.
Exactly. But I think a very important question is, how can people find out more about Very and what you're doing, and just everything about Very, basically? What are the best channels to find you?
Yeah, I'm sure he'll jump in here now, but for me, the 2 biggest places I always point people are, verytechnology.com, the website, and LinkedIn. Everyone today, LinkedIn. You can find me, Daniel Fudge. Not a lot of Fudges in the world, so I'm not terribly hard to find. So, and anyone reach out to me at all times.
Yeah, nothing to add. I always think it's, on LinkedIn, it's like folks that aren't on it. I'm like, man, this is not the hill you want to die on, man. Like, this is the platform that everybody uses to locate each other. So yeah, verytechnology.com, and then we're pretty vocal on LinkedIn.
Yeah, and I'll just add, I guess, a question for you, Ryan, as well, on the podcast, over the air podcast, which we have just appeared on. So check out that episode with my colleague Rob now. But so what type of topics do you cover on there? And you might say IoT, which is great, but I mean, give us a flavour of what people will find, type of guests and topics on the podcast.
Yeah, so that's a great question, and not only have we had Senseye on the show, but we've had Siemens, a couple of different ways. So I think we've had a couple of different slices, but yeah. So I love to talk with C-level folks about things that went wrong in their journey. I'm looking for examples of times that something caught on fire and what they learned from that. Sometimes the caught on fire is a metaphorical moment, but sometimes it is actual flames. And I think our audience is tuning in to hear about scar tissue and what they can learn from folks that have been down some of these paths and learned some expensive lessons. You hear over and over that failure is a good thing and you learn a lot from it, but sometimes other people's failure is pretty valuable. So I think I look at China's space program. I think they've learned a lot from the U.S. space program in terms of mistakes they don't need to make because we made them and put that information in the public domain and so forth. So yeah, so we're a shorter format than this, so we're about 25 minutes. And I always tell people, no pitches. I want to go right to, what went wrong on a journey that went right. So, would love to have anybody from your audience jump over and join us. And of course, we would encourage our audience to come over here and do the same.
Yeah. Absolutely. And so what we'll do is we'll link to both the very website and over the air podcast as well, so people can easily sort of check that out and follow up as well. And actually, normally we have a lot shorter episodes, but this was such a great topic. We've sort of got a bit deeper into it, which isn't a bad thing at all. I think it's been a very good thing. Like I said, it's flown by. So as we conclude, I'd just like to thank you both again for joining us today and sharing your insights. It's been been great for me. I'm sure definitely great for our audience as well. So aside from that, thank you both for joining, and thank you everyone for listening, and we'll see you on the next episode.
Awesome.
Thanks for having us.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.